Hello and welcome to the course of Material Science and Manufacturing Process. And this is your 25th lecture, and we are in the chapter of machining and machine tool. And today we will be starting your first machine tool, and this machine tool is very important to understand. So we will know about lathe today. So lathe is a machine tool. So the definition, I guess I have given the definition of the machine tool in the introductory class for machining. So again I am repeating that definition, that is machine tool. What is machine tool? Machine tool is a device which can transmit and transform. Machine tool is a device which can cut the material, which can cut the metal by in the form of chip by using a cutting tool. So machine tool is a device which can cut the material in the form of chip by using a wedge shape tool, that is called cutting tool. So whichever machine that can cut the material in the form of chip, that can be used, that can be referred as machine tool. So here we will be studying about lathe today. For so the lecture objective today is to know about the classification of the lathe, is to get an insight of the kinematic system of a central lathe. That means how the motion will be transmitted, that we will know. Next we will know about the working principle of the lathe machine by using your some of by and after knowing the name and function of different part of lathe. I hope you have some idea about this topic. So but also we are seeing about lathe. Let's start. So lathe are very versatile, are very versatile and widely used, and they are classified according to several aspects. First, according to configuration, how they configure, according to that we can classify the lathe as horizontal lathe. Horizontal lathe are most common and agronomic convections. So agronomic convection means the design that is mostly suited for human application. So the mostly suited human application application lathe are horizontal lathe. There are some configuration that is called vertical lathe. In vertical lathe occupies less floor place. Only some large lathe are of this type can be occur. So maximum lathes are in type horizontal type lathe. Okay. Now according to purpose of use, lathe can be differentiated or classified in three terms. First one is uh, general purpose, second is single purpose, and third one is special purpose lathe. The general purpose lathe are very versatile, where almost all possible type of operation are carried out on wide range of size, shape and materials of jobs. For example, central lathe, these are central lathe. This is a general purpose lathe. So in general purpose lathe, again I am saying that all possible types of operation are carried out on wide range of material, wide range of size, shape and the materials of the job. So that is what general purpose lathe is. Next, single purpose lathe, only one, occasionally two uh, type of operation is done on limited range of size and material of jobs. For example, facing lathe, roll turning lathe, etc. So one or maximum two operation can be done in a machine, and or in a lathe, and the the size and material of the job is also limited. Now, for special purpose lathe, where a definite number and type of operation is done repeatedly over a long time on a specific type of blank. For example, means when special purpose lathe is when the lathe is used to make one specific job only, one specific workpiece, one specific job only with one specific shape. So that is known as your special purpose lathe. For example, gear blank machining lathe, that is one of the special purpose lathe. Now, according to size or capacity, the lathes can be lathe can be of small or low duty of a low duty lathe. So in such lathe or light duty lathe, up to 1.1 kilowatt power will be there, and only small and medium sized jobs are generally jobs of soft and easily machinable material can be machined. Next, medium size or medium duty job, medium size or medium duty lathe. These medium duty lathe are lathes of power nearly up to 11 kilowatt, are most versatile and commonly used. Next is large or heavy duty lathe. Large or heavy duty lathe, and there is one special type, that is mini or micro lathe. These are the tiny mini or micro lathes are tiny tabletop lathe used for extremely small size job and precision work. For example, switch type automatic lathe. According to the degree of automation, lathe can be classified such as non-automatic, that is almost all the handling operation are done manually. For example, central lathe. Next is semi-automatic lathe. Nearly half of the handling operation, irrespective of processing operation, are done automatically, and the rest is done manually. That is known as semi-automatic machine. And the example of the semi-automatic lathe is capstan lathe, turret lathe, coping lathe, and relieving lathe. Next is automatic. Almost all the handling operation are done, and obviously all the processing operation too are done automatically, then that is known as automatic lathe. For example, single spindle automat or automatic lathe, switch type automatic lathe, etc. These are the according to the configuration. According to the type of automation, the lathe can be distinguished into term. First one is fixed automation. That means that is the conventional lathe. The example is single spindle automat, switch type automatic lathe, etc. And flexible automation. In the flexible automation, the examples are the flexible automations are the modern technique or the CNC technique. So examples are CNC lathe, turning center, etc. According to the configuration of the job being handled. So by handling the configuration of job handling, the lathe can be of butt type, where the slender or rod like job being held in collets. Next is chucking type, disc type job being held in chuck. Next is housing type, odd shape job being held in a faceplate, that is housing type. So according to the configuration of the job being held, these are the type of the lathe. Next is according to precision, how precise the operation is. According to that, the classification may be done. First one is ordinary lathe, next is precision lathe. In the these sophisticated lathe, that is precision lathe, are meant for higher accuracy and surface finish of the machine surface, and the process is relatively more expensive. Next, according to the number of spindle, we can have single spindle lathe, that is most common, or multi spindle lathe, that is 2, 4, 6 or 8 spindle may be seen. Such uncommon lathes are suitably used for fast and mass production of small size and simple shape job. Now this is an example. This is an photograph of a bench lathe. This is a photograph of an engine lathe. This engine lathe or center lathe are the most common lathe that you can see in the workshop also. See the part here. Here is a headstock and a tailstock. In the tailstock there is tailstock wheel. In the headstock assembly we can see the spindle speed selector. We can see the spindle. We can see the feed selector. We can see the clutch. We can see the chip pen. We can now in the bed part, in the bed what we can see in the bed, we can see that there is ways, that is V ways, that in which the carriage moves, and in the carriage there is 3 or 4 part. First is tool post, next is compound rest, next is cross slide, and last one is apron. And in the apron part there is also a clutch. The longitudinal feed control is there, split nut is there or half nut is there, and these are all the part. And here feed rod and lead screw are given in 2 different rod. In some machine this feed rod and lead screw are completely are in the feed rod, and your the lead screw and feed rod, in some case both of them are made on a single rod only. Now this is a tool room lathe diagram. This is a special purpose lathe or gap bed lathe. Now here also a schematic diagram is given, where you can see in this 3D figure. In this 3D figure you can see there is a spindle, work holder, workpiece, cutting tool, compound rest, cross slide, tailstock assembly. Ways are done in the bed, and this is tailstock assembly. This is bed. This is lead screw. Carriage handwheel is there. There is cross slide handwheel, and this carriage moves over the lead screw and feed rod. So that is it. Now here also another in another picture the of the lathe, all of the parts are described. Now this is also similar picture. These pictures are given for better understanding. Now here also you can see the in detail diagram. You can see the detail diagram. If in exam you have to draw the lathe, then you have to draw like this. This one you should draw. Now I am coming to the part of the lathe. So first it is lathe bed. What is the use? It supports all the major component of the lathe, as it is the base of the machine. These have large mass, rigidly built as a single piece, casting from grey or toughened cast iron to resist the deflection and absorbs the vibration generated during the cutting process. 3 main parts of this bed is head, tailstock, and carriage. 3 main parts, that is head, tailstock, carriage, are mounted on the lathe bed itself. Now headstock. It is a part which secures the permanently at the left hand end of the bed, and supports the spindle and equipment with power driving mechanisms such as motor, pulleys, B-belt, etc. for spindle at various speed of rotation. And it have a hollow spindle through which the work holding devices such as clutch, it have a hollow spindle to which a work holding device such as clutch, collets, that this can be attached with the spindle. So this is for headstock. Now tailstock. This headstock is called live center because the as here in this center the job is rotating or the spindle is rotating, so that's why it is called live center. Now tailstock can be said can also be told as loose headstock or puppet head or dead center. This tailstock is mounted on the inner ways at right hand end of the bed, which can slide along the ways and can be clamped at any position and supports the other end of the workpiece. It is equipped with a center that may be fixed, that is called dead center, or may be free to rotate with the workpiece called live center. So drills and reamers can be mounted on the tailstock wheel, a hollow cylindrical part with a tapered hole in the tailstock. This is known as quill. And the drills and reamers can be mounted into the quill to drill axial holes in the workpiece, and quill can move in or out with the with hand wheel. So see here, center barrel or spindle tailstock is shown here. Now the carriage. The carriage slides along the guideways between the headstock and tailstock, and it consists assembly of saddle, cross slide, tool post, compound rest, and apron. The main function of carriage, carriage is to hold the cutting tool, and move it to given longitudinal or cross sectional feed to it. The operator moves the carriage manually by hand wheel or automatically by engaging feed shaft with the carriage feed mechanism. So this is the pictorial view of the carriage only. Now saddle part, the part of the carriage which slides along the bed with and support the cross slide, compound rest and tool post is known as saddle. Now cross slide is mounted on the top of the saddle and always moves in the direction normal to the axis of main spindle. It can be either operated by hand or by means of cross feed screw, or may be given power feed through the apron mechanism. So this is your saddle and carriage shown here. Now compound rest, it is mounted across the slide on the cross slide and carries the graduated circular base called swivel plate, and the upper part is called compound slide, and it can be moved by means of compound rest feed screw. Tool post is the most part of the carriage used to holding the tool, topmost part of the carriage used to holding the tool in tool holder in position. Now apron is the hanging part in front of carriage. It serves as a housing for the number of gear trains through which the power feeds can be given to the carriage and cross slide. Now feed rod and lead screw. Feed rod is powered by set of gears from the headstock, and it rotates during the operation of lathe and provides the movement to carriage and cross slide by the means of gears, friction clutch, KOS, along with the length of the rod. Lead screw, it transmits the power to the carriage through a gear and clutch arrangement in carriage apron. So working principle: the lathe is a machine tool which holds the workpiece between two rigid and strong supports called center, or in a chuck or faceplate, which resolves as shown in figure. The cutting tool is rigidly held and supported in the tool post, which fed against the revolving work. The normal cutting operation are performed by the cutting tool fed either parallel or at night, or at right angle to the axis of the work. The cutting tool may be also fed at an angle relative to the axis of work from the machining work for machining tapers and angles. So that is the working principle of the lathe. Thank you. Hope you enjoy this lecture, and if you have any problem, you may ask in the live class. Thank you.